Students, in our previous video we have solved a number of problems related to Ethiopian in university entrance examination in English, and today we begin from where we stopped last time. This is grade 12 mathematics Ethiopian university entrance examination part 13, presented to you by Umar Adam. Now let us begin with this question. This question says, the indefinite integral of 3 over x dx is equal to. That is what the question says. It's a very precise and short question, but let us see how to answer. In the new textbook, there is only the indefinite integrals of power function, but unfortunately this particular question appeared on the exercise part of student's textbook, which is why I brought here, because you haven't learned how to integrate such question, and therefore let us begin. Here in indefinite integrals, you can solve any power function. You can integrate any power function, but here 1 over x dx, the integration of the indefinite integral of this one always becomes ln, the natural logarithm, ln of, in the absolute value, x plus c, any constant c. That is how to integrate 1 over x. Here the absolute value of x is needed because the domain of any logarithmic function, which is written in this form, is greater than 0. 0 and below 0 cannot be allowed in logarithm here. Therefore, here we know that ln x means it is logarithm of x in base e, where e is a rational number which is neither terminating nor repeating. Therefore, we call such a logarithm a natural logarithm. Now let us come to our question. Here, as you can see, 3 over x dx, the integral of 3 over x dx is nothing but it is simply just 3 ln of the absolute value of x plus c. Therefore, the answer in this case is A is the correct answer. Let us come to the next question. Question 22. It says, let f of x is equal to 9 over x squared, and b an element of real number. Let us call b be any real number. If the definite integral from 1 up to b, f of x dx is equal to 6, then what is the value of b? That is what the question says. And therefore let us see what are given. First, collect what are given in our question. Given here, f of x is equal to 9 over x squared, and then this integration, this definite integral is given. Therefore, we begin from this one. Replace f of x by this expression, 9 over x squared, since our f of x is equal to 9 over x squared, and then change 9x squared, or rewrite 9x squared as 9x the power of minus 2 in power function form, and then apply the integration. Remember, we say that the integral of power function x the power of n dx is equal to, remember this one, always don't forget the integral of this particular function, x the power of n plus 1, and then write n plus 1 again also as a denominator of this one, which is n plus 1, plus a certain constant number c. That was how we define the indefinite integral of x to the power of n dx. Then let us begin here. 9x to the power of minus 2 dx, the integral of this one becomes 9 times x to the power of minus 2, since our n is minus 2, minus 2 plus 1 over, write this expression in the denominator, which is minus 2 plus 1, and then minus 2 plus 1 means it is minus 1, multiply minus 1 by 9, it becomes minus 9. X to the power of minus 2 plus 1 means x to the power of minus 1. Again, we can rewrite x to the power of, by applying the rule of exponent, x to the power of minus 1 means it is equal to 1 over x. 1 over x. And therefore, what we have to do is just evaluate minus 9 over x from 1 up to b. First, replace x by b, and then subtract this expression and also replace x by 1, which means minus 9 over b, make it minus into, since we have original minus here, minus 9 over 1. First insert b here in x, and then after making here, after subtracting this expression from, subtracting this one from this one, then what we have to do is, since the definite integral of f of x dx is equal to 6, it is given, what we have to do is multiply minus by minus, it becomes minus 9 over b plus 9 is equal to 6. From this, we can evaluate the value of b. It becomes, then collect the number on one side and leave the variable on the other side, which means minus 9 over b is equal to 6 minus 9. And then minus 9 over b will be equal to minus 3. And by put b here, minus 3, just move b in here and minus 3 as a denominator right here. b is equal to minus 9 over minus 3, which is equal to minus cancel minus, 9 divided by 3 gives us 3. Therefore, the value of b, which when substituted here, gives us 6 by integrating 9 over x squared, is simply 3. And therefore, your answer should be C. If you say C, then you score a point. Now let us come to the next question. This question says, it's a little bit complex question actually. Therefore, let us try. It says, let f of x is equal to ax cubed minus bx plus 2, where a and b an element of real number, such that a must be different from 0 in this case. If f prime of 1 is equal to 11, the derivative of this function at 1 gives us 11, and the definite integral from 0 up to 1 f of x dx is equal to 20, then what are the values of a and b? That is what the question says. Now, as you can see here, we have f prime of 1 is equal to 11, and also we have this definite integral. By using these two, then we will get two linear equations as such here, given our f of x is equal to ax cubed minus bx plus 2, and f prime of 1 is equal to 11, and the integral from 0 up to 1 f of x dx is equal to 20. First, let us use this one. From f of x, we have f prime of x, the derivative of this function, is equal to 3ax squared minus b. Since f prime of 1 is equal to 11 is given, then what we have to do is replace x here by 1. F prime of 1 is equal to 11 implies 3a minus b is equal to 11. And call this one equation number 1. Call this one equation number 1 and put it in a box we will use later on. Now, using the derivative, using these two, we have found this linear equation involving two variables. And also, we can't solve this one since it involves two variables. Here, we have to get another similar linear equation. That equation will be obtained from this one. Now, from the integral from 0 to 1 f of x dx is equal to 20, we will have 0 up to 1. Our function f of x ax cubed minus bx plus 2 dx is equal to 20. And then integrate this one first. Integrate this one. It will be ax is the power of 4 over 4 minus bx squared over 2 plus 2x. Here x cubed will be, after the integration, it becomes x the power of 4 over 4. And here this x, after the integration, it will become x squared over 2. And since this is a constant number, its antiderivative is going to be 2x. Then evaluate this in after the integral, this expression from 0 up to 1. First, replace x by 1. Put 1 in place of x. It becomes here 1 over 4 times a over 4 minus, again, 1 square means it is 1. 1 over 2 multiplied by minus b, it becomes minus b over 2. Plus, again, 1, our x is 1. 2 times 1, it becomes 2. And the minus, if we put 0 in place of x, it becomes 0. No need to write that one. And then convert this expression, this equation, or write this equation as a linear. To do that, what we have to do is multiply both sides of the equation by 4. Sorry. If we multiply both sides by 4, 4 times a the power of a over 4 becomes a, 4 cancel 4, minus 4 times b over 2 is equal to minus 2b, plus 4 times 2 is equal to 8, and 4 times 20, it is 80. And then move the number on one side, and those that contains variable, leave it on the other side, which means a minus 2b is equal to 80 minus, move this one to the right, it becomes minus, here it is positive, therefore it becomes minus, 80 minus 8, it becomes 72. Therefore, a minus 2b is equal to 72. And call this equation second equation, or question number 2, and put it in a box. Then combine the two. Combine this one and this one. It becomes system of linear equation involving two variables. From star 1, as you can see here, from this star 1 and the second star here, if we combine, we get the system of linear equation involving a and b, which is written as 3a minus b is equal to 11, a minus 2b is equal to 72. There are many ways to solve such system of linear equation. In grade 11, you have learned 3 methods to solve system of linear equation. In grade 9, you have learned those 3 methods. The first method is graphical method of solving system of linear equation, and the second one is elimination method of solving system of linear equation, and the third one is substitution method. And also in grade 11, you have learned the Gaussian elimination method. That is actually similar to what we call what you have learned, the method you have learned in grade 9, but the Cramer's rule is also different. You can apply Cramer's rule to find a and b, A and b. After solving this system of linear equation, we will have a is equal to minus 10 and b is equal to minus 41. How we can use either of those methods? Let us see. Apply the elimination method actually in this one. Let us apply or substitution method or elimination method. What we have to do is write b in terms of a here. B in terms of a. It becomes 3a is equal to, 3a minus 11 is equal to, since b here we have b minus, then it becomes positive, is equal to b. Write first this one. This is known as substitution method. And then substitute this value, this b, the equation you have obtained here, in the second equation. It becomes a into a minus 2 times. Instead of writing b, you can substitute b for this one here, 3a minus 11. 3a minus 11. Replace b by this one. And then this expression is equal to 72. In that case, now the equation is simply a linear equation. No more system. It is a linear equation which involves one variable only, a and a here. Then this becomes a into minus 2 times 3a means it is minus 6a. And also this minus 2 must multiply also minus 11. Minus 2 times minus 11 means it is positive. Minus multiplied by minus becomes plus, and therefore it is 22. Then collect the number on one side and leave the variable on the other side. Here is 72. A minus 6a means minus 5a. It is minus 5a. Minus 5a is equal to 72 here, 72 minus 22 here. What is the difference of the two? It becomes minus 50. Positive 50. Minus 5a is equal to 50. Then divide both sides by minus 5. Divide both sides by minus 5, it will become here 50 over minus 5. When 50 is divided by minus 5, it becomes minus 10. Therefore, the value of a is minus 10. That is how to apply the substitution method to find the variables involved in system of linear equation. Once you get a, then substitute this value minus 10 in place of a here, multiply it by 3 and subtract from the result 11. Subtract from the given result, which means 3 times minus 10, it is minus 30. Minus 30 minus 11 becomes minus 42. Therefore, we have found the value of b as well. Therefore, the solution, the value of a, let us return to our choice here, multiple choice. Here it is a is equal to 11 and b is equal to 41. This is x. A is equal to 10 and b is equal to minus 41. This is also x. And the c, it says a is equal to minus 10, b is equal to minus 40. And therefore, this one is the correct answer. Okay, it is weird actually. Suppose this one appeared on the examination that you are going to take, and then unless you try to, you are able to solve as such, then it is a disaster, I hope. Now, let us see question number 25. It says, suppose that f is differentiable function such that f of g of x is equal to x and f prime of x is equal to 1 plus f of x squared. Then g prime of x is equal to, that is what the question says. Find g prime of x. Now, what are given? The given one here, first, f of g of x is equal to x is given, and f prime of x is equal to 1 plus f of x the whole square is also given. Now how can we separate g of x from this composition of function? Because we are asked to determine g prime of x. Therefore, what we have to do is we will begin from this one. We begin from this one. F of g of x means this is composition of a function, composition of g by x. Composition of a function can be derivated by applying the chain rule. Here we begin from this one, then derivate both sides. Derivate this side as well as this side. The derivative of f of the derivative of this one, just apply the chain rule here. It becomes f prime of g of x, and then again multiply this one by chain rule. Again derivate g of x also. It becomes g prime of x. This is known as chain rule. And the derivative of x on the right side is simply 1. It is 1. Now, to save time, let us see the one I have already here solved here. Derivative here. F of g of x, the derivative of this one must be equal to derivative both sides here, x, and then it becomes f prime of g of x, g prime of x is equal to 1. And then since we are asked to determine g prime of x, what we have to do is divide both sides by f prime of g of x, which becomes g prime of x is equal to 1 over f prime of g of x. Since again our f prime of x is equal to 1 plus f of x is a whole square, and also g prime of x, or I mean f prime of x, g of x is also here given. What you have to do is just replace x by g of x. This implies this one, f prime of x is equal to 1 plus f of x whole square, implies f prime of g of x is equal to 1 plus f of g of x is a whole square. Since also f of g of x is equal to x, then replace this composition of function by x. It becomes f prime of g of x becomes 1 plus x squared. Therefore, g prime of x, the derivative of g with respect to x becomes 1 over, since it is 1 over f prime of g of x, and the f prime of g of x is also equal to 1 plus x squared, then replace this denominator by 1 plus x squared. That is how can we solve g prime of x. Therefore, A is not the correct answer, but B is the correct answer. That expression which we have found is in choice B. Okay, let us see the last question for this part. This question number 26, it says, if m and n are positive integers, then for what value of x, f of x is equal to x to the power of m multiplied by 1 minus x to the power of n has absolute maximum value on the interval from 0 up to 1. That is what the question says. What value of x gives us the absolute maximum of this function? The absolute maxima and the absolute minima combined, the combination of the two is said to be absolute extremum. Absolute extrema of a function. The absolute extrema of a function for a function which is continuous on a closed interval, closed in the bounded interval, can either be obtained at the endpoints of the interval, or somewhere in between at the critical point, at the critical number. Therefore, just try these endpoints 0 and 1 first. F of 0 is exactly equal to 0, and also f of 1 gives us also 0. f of 0 is equal to f of 1. Therefore, now the absolute maximum can be obtained at the critical, can only be obtained at the critical number in that case, since m and n are integers. That critical number can also be obtained by derivating the function. The critical number always obtained at f prime of x, at where the slope of the tangent line is 0, which means the tangent line at the absolute maxima or absolute minima or local maxima or local minima, the slope of the tangent line is always 0, since it is horizontal line. Okay, now let us derivate this one. Derivate f prime of x. F prime of x is equal to, apply the, now, okay, now to derivate this function, what we have to do is apply the product rule of derivative. Product rule means, suppose f and g are two functions in x. Suppose it is not necessary actually to write here x. Then f times g, the derivative of f times g becomes f, the derivative of f with respect to x, multiplied by g with respect to x, plus f multiplied by the derivative of g with respect to x. That is how to derivate the product of two functions. Now, suppose that x the power of m is one function and 1 minus x the power of n is also another function. Then to derivate the product of these two, what you have to do is first derivate x the power of m. It becomes m times x the power of m minus 1, and then multiply directly by this one. It becomes 1 minus x the power of n, similar to this one. The first one, f, just suppose that this is f of x, and suppose that this is also g of x, and therefore f prime times g plus f g prime here. That is what we have to do here. M, the derivative of x the power of m, becomes like this one. They multiply directly by this one, and then plus again derivate this one. I will tell you this, where this minus comes from. Just write this one, x the power of m, and after the derivative, when we derivate this one, x the power of 1 minus x the power of n, means n times 1 minus x n minus 1. Again, by chain rule, derivate this, the inside this expression, 1 minus x. It becomes minus 1. That was where this minus comes from. Then by chain rule, when we derivate this one, let me show you if you have any problem with this one. If you have any problem derivating such kind of a function, here the derivative of this one, once we derivate this one, if we derivate this one, it becomes, sorry for this one, it becomes, this is exactly equal to n into 1 minus x the power of, first we derivate the power n minus 1, and then again by chain rule derivate 1 minus x. The derivative of 1 is 0, the derivative of minus x is minus 1. Then multiply minus 1 and n. It becomes minus n times this expression. Therefore, here minus n x the power of m, 1 minus x the power of n minus 1. Now let us rearrange this one. Common out x is the power of m minus 1. Common out x the power of m minus 1 and 1 minus x the power of n minus 1. Here, once we common out x the power of m minus 1 and 1 minus x the power of n minus 1, what is left here is m into 1 minus x only, minus here again n times x. After we common out this expression, they leave behind minus nx and also 1 minus x. If we multiply these two expressions by this one, it will become mx to the power of m minus 1, 1 minus x to the power of n. And also if we multiply this expression by this x to the power of m minus 1 and 1 minus x to the power of n minus 1, it will become nx to the power of m 1 minus x n minus 1. Therefore, these two expressions are equal, they are the same. But here, to find the critical number always obtained at f prime of x is equal to 0. That is what we have said. Here, f prime of x is equal to 0 means this derivative must be equal to 0. Either this one is 0 or this expression is 0, which means either x to the power of m minus 1 into 1 minus x to the power of n minus 1 is equal to 0, or m times 1 minus x in bracket minus nx is equal to 0. From this first equation, we will get x is equal to 0 or 1 minus x is equal to 0, and or m times 1 minus x in bracket minus nx is equal to 0. From this, we will get x is equal to 0, x or x is equal to 1, or m minus mx minus nx is equal to 0. Let us rearrange, collect those expressions, those terms that contains x or together, and collect the one that doesn't have x as the one that is not written here as a coefficient here, m, which means m is equal to, in this case, move this one to the right, m is equal to mx plus nx. It becomes positive. And then common out here, x, we have x in this term, we have x here, we have also x. If we common out, then it will leave behind m plus n times x is equal to m here. Then divide both sides by m plus n, it becomes m over m plus n. Now remember, we say m and n are positive integers, then m divided by m plus n means it is a number which is between 0 and 1. It must be, since m and n both are integers and then both are positive. Therefore, the value of x for which this function has absolute maximum value on this interval is equal to m over n. That is it. Now, if you like this video, please subscribe, share, and like, and we will see soon in our next video. Bye, please.